Good morning. Back to work here on some stuff. I have a few different things to look at. Okay, so this did not behave nicely. It's fairly odd. Wonder if it's these. I might have some ideas on what's going on here. This is so similar to the other training curve, the other sweep curve, but just a little bit off. This one's just slightly better developed. It's almost the same sweep, to be fair. They both have the same problem of doing these short, stupid runs. Morning. We're back doing hyperparameter sweep algorithm development. This is the new algorithm I've been working on, and it's mostly very good. It just has a few quirks with it. I'm trying to figure those out. At the moment, the problem is that wherever it tries to search, it gets very good results. But for some reason, it tends to after it does some good work, it just pushes all the way down to the bottom over here, and it tries to do a bunch of very quick experiments that can't possibly get any good results. So we have to figure that out. Move these windows around a little bit. So let me check something here. I want to see what we're logging, the current version. So rating we do distance to nearest, cost, and score. Okay, so these stats should be correct. So what this is telling us is that it predicts that it's going to, this run that it just has here, this is just one of the last runs. It predicts that it's going to score negative 19.256, which is a terrible score, but it's better than this nearby score. It's saying it's right next to an existing Pareto point, and it's going to get a rating of 003. Well, at least we have a better way to interpret this now than before. So this is basically the model doesn't think that it can improve anywhere in the Pareto front. So for whatever reason, it thinks that this is the Pareto front here, and it cannot improve. Warning. I mean, at least now we have a clear picture of the problem, because this is, before we had like this multi-component scoring function. Now it's a very easy to interpret scoring function. It's just maximum improvement over nearest Pareto point. So basically this thing thinks that it can't improve over the front, so it stops trying. And it notices, hey, there's a lot of variance really on these very low cost runs. There's a lot of variance, so maybe I can improve a little. It does, it kind of draws out this portion of the curve here. But that shouldn't be very valuable. 003. Now, is this the latest one? No, this is not the latest one. It's going to be the same thing with this, I assume, but it's very slightly different. Yeah, we have this curve. Just stumbled on GitHub, repo looks cool. We've got on puffer.ai. They're all playable. This is the only one that doesn't have an agent on it. So this is a trained reinforcement learning model playing Breakout in your browser. You can also hold Shift and take over for the agent like this. You can play for him. If I just drop Shift, it'll take over. Same thing for all of these things. We've got multi-agent snake. We've got more complex stuff. This is neural MMO. My favorites. It's pretty much a big MMO. Got a MOBA in here. We've got lots of different things. These are all ultra high performance tasks for reinforcement learning. So I work on those some of the time. I merge those in from other contributors, other portions of the time. And sometimes I get stuck doing algorithm development, which is what's going on right here. We're currently trying to come up with a better way of finding the good settings to train these agents with. And well, that requires a lot of experiments. Thank you. And this is what I'm doing full time now, is I'm trying to make reinforcement learning stable and consistent. I have a quick start guide, though you do need to at least have something of a programming background. But the quick start guide we have here is a very easy way to get involved with this stuff. Like, we have several contributors who came in with just a software engineering background, no AI background, and have very quickly gotten to be quite competent. I mean, there's stuff in here that took me many years to learn. It's a pretty quick read. And I don't link you dozens of papers. I link you like a few papers that you should read, and maybe 10 over the course of a couple months you should read. Okay, so there is one possible hypothesis here, right? It's kind of a long shot. This is the Pareto front right here. So it's this point. There are a few points like here, here, and here, I believe. But then it's this point, this point, this point, this point, this point. Oh, it's not random at all. You know what random looks like? Random looks like everything's like down here for the most part. This is the score front. So each of these points is an experiment that's been run on Pong. And this is the cost of that experiment. So here, this is that you were able to get 18.9 score on Pong in 18 seconds. Holy, we got an essay from Captain. Merging impulse into puffer. I know we talked about CMake. That might be long-term. What has to happen in the short term to get merged? Either get it working with a set of tools, or we integrate CMake. Yes, it's got to be one of those two things, basically. We can try CMake in dev if it is quicker for you to get it to work that way. We can do that. I'm not committing to doing CMake for all of Puffer, but we can try it and I can play with it and I can see if I hate it or not. I think I owe you that much at the least, right? I know I'm being unreasonable there, and I'm choosing to be unreasonable because this is like a trust or instincts thing. I could be completely wrong, but this is the type of stuff that has also saved Puffer from lots of bad stuff before. So If that's the easiest thing, then yeah, we can just merge in CMake. If all the M's build, then we're good. I'm fine doing a whole bunch of infra and stuff for Puffer as soon as I have this algorithm in a good spot. But this algorithm at this moment for like my dev bandwidth, this is the main thing I'm focused on because this is going to be so important and useful. Speaking of which, there was science side stuff that you wanted to get involved with whenever you are less busy, right? Okay, I think that I figured out what this problem is here. Extrapolating for physics. So, the thing is Pareto optimality, which if you're not familiar with, it's fancy, but it's very simple to explain. So Pareto optimality says that a point is Pareto optimal if there's nothing up and to the left. So if there's nothing that's either faster with the same score or better but not more expensive, then the point's Pareto optimal. There's nothing up and to the left, I should say. So this point is basically the outline of all the points. Been having problems with box 2. I think the RAM needs to be tested. Okay, I can do that. Captain, make sure you have all your stuff synced because I can go. Basically, what I'll go do is I'll go look at it and see if I left XMP on it. If I did, I'll disable that. But if it's not XMP, I might just reinstall the OS because Ubuntu's been better for us lately. It's like a 10-minute thing for me to reinstall an OS now as well. Same everything as before. Welcome, YouTube folks. Ten minutes took me 3 hours on Friday. Well, I mean, we just have our server install. Going through the installer only takes a couple of minutes. And then we have a setup script that just sets up the boxes for us. And then like all our stuff's already on a container, so it's really easy. My container still exists. If I reinstall the OS, it'll nuke the current container and it'll put a new one on there. So you'll get a container, but it'll nuke the container and you'll get a new one. So if there's stuff on there that you need, like I mean, ideally, right? Like ideally you should have like any extra stuff that you need to set up and install impulse wars and such should be in the setup scripts. So that like the goal is that these containers should be very quickly reproducible. So that like it's just like a quick setup whenever you need a new one. If you say like, hey, latest Clang builds faster code for us, by the way, you're allowed to do things like send me snippets to add to the, or you're allowed to PR stuff even to the Docker files. If you say, hey, like we need like new Clang because it builds faster code for this, like you're allowed to just PR stuff to the Docker files. configure it. Yeah, so ideally what you should do is you should just like whatever like basic stuff, like here, any like reasonable system tools that aren't huge, I'm just gonna let you put on the container. I care way less about like adding a little bit to the container size than I care about like like making like setup stuff or user bugs or whatever. Just make sure you PR it to the right one. It's a 3-layer build. So we have a base image where like all the core system packages go. Usually the easiest thing is to add new experimental utils to just the puffer tank file to that one, because that's the quickest to rebuild. And then we move stuff back up the chain, as we decide, okay, yeah, we need this longer term. I bet it's resampling causing this bug. Weird Python versioning. What weird Python versioning is there? Does your dissertation talk about the graphic plugin? Is it new research? It's new research here. It's based on this. By the way, this is linked in the quick start guide as well. But in View AI Carbs, there's a paper on this as well. It's a very mathy paper. But the goal is to do Pareto optimal hyperparameter optimization, which means that your algorithm is trying to draw like an outline around all these points. You're trying to figure out what is the best experiment you can run for every cost budget, which is for how long you're willing to run the experiment. So if you're willing to run the experiment for, here 5 seconds, 15 seconds, 30 seconds, you want the best possible performance. Python 3.11 is the only. You said Python does and Python 3 don't? I mean, ideally we'd have it. Python 3.11 is the only Python binary. Okay, that's weird. We've used PufferLib as low as Python 3.8, so I don't know what's going on with that. Like we used 3.8 on it with Isaac and it just worked fine. I think the only thing I know that doesn't work is if you go above 3.11, maybe it's above 3.12, there are some like external third-party environments that won't work. So like if you include those extras, they don't work. But Puffer shouldn't have weird dependencies. Like we really don't do that much. If there's anything weird, yeah, absolutely fix. Oh, that's weird. Yeah, that shouldn't be the case. If you've been seeing me do that on my container, that's because I was doing Isaac dev, and I installed Python 3.8 in that, and I broke some links. That shouldn't be the case in. That's not the case in a fresh container, I don't think. I just set up a new one just like yesterday, and it was fine. Are you getting that problem on yours? Hmm. Weird. And all these stability issues are ridiculous. Magnetics, we want to reduce the area in the BH curve. We're trying to maximize it. So the goal here is, right, that this is, the x-axis is how much time we spend running an experiment, right? We can just train for longer. The y-axis is the score. This is how well the experiment does. So for however much we're going to put into the experiment, however much we're going to spend, we want to maximize the score. And this is defined by the hyperparameters that are used to run the algorithm. So if we don't spend any time running the experiment, you're not going to get any score. If we spend 10 seconds running the experiment, the best that we can do in 10 seconds is this point right here. You know, there's nothing that for 10 seconds, there's nothing for 10 seconds that does better than that point. So that point is Pareto optimal. At 15 seconds, the best point is right here. And at 20 seconds, the best point's right here. So we're trying to expand this Pareto front. No, it depends on the environment. It shouldn't be exponential. Definitely shouldn't be exponential. It's usually going to be logarithmic or log bound. This looks exponential to you. This is bounded. This is like a log bound. It's bounded at 20. It's like log bound, the shape of this curve. Exponential would be the other curvature. And what I think what's happening probably here, I think I've identified the issue. I think that it's going to be very noisy. Sometimes you can just get lucky, is the thing. And the same hyperparameters aren't always going to give you the exact same result. So if these points got lucky, then the Pareto front is actually probably not this high out. And then it's going to say, well, I can't improve over any of these points because these points are already unrealistic. So it's just going to run stuff over here. I think that's probably what happened. So I got to think about the resampling. Feeds back into training. Yeah, in a way. The algorithm has a set of hyperparameters, right? Like the learning rate, the entropy, gamma and lambda. There are a bunch of these parameters. And this is what this algorithm is trying to set. It's trying to find the optimal hyperparameters for training. I think we got to start on this. I think I found the issue and we just got to start on this. Can you show me an example? There you go. That would be the Pareto curve as defined by the current data. But the thing is, I think that these points are noisy. So I think what's happening is that this is an overestimate. So the reason that I think the algorithm is crashing is that this point should probably be down here. And this point should probably be like here and, like this and so on. So I think that what's happening is that because you have these overconfident estimates, the algorithm stops sampling in this region because it can't improve. Yeah, no, it's just the best performers at each cost. And I think what we need to do is we need to resample here. This is results of a run, Captain. So we have this plot. This is the simplified one. So it does like just a tiny bit worse than the previous one. I think it's just noise though, because the algorithm is very similar. We simplified a couple of things. This is the best graph that we have at the moment. And the results are very, very good. It's just that it degenerates. So like after 100 runs or something, it just starts sampling right here. But this portion of the curvature is really good. Like this is 20.54 in less than 20 seconds. So this is really good. But I think like points like this and stuff, we get overestimates. The problem. Okay, I need to modify. There's quite a bit I actually need to modify to support this feature, which is annoying. Well, I'm going to try to focus a little bit here, and the goal here is going to be to add a resampling mechanism by which you can essentially run the same trial multiple times in order to get an average performance, so that you don't get overestimates on the Pareto front. Well, it was going to have resampling. I just never bothered with it because it's a little annoying to implement. So I'm adding this now. So yes, it does as well as it does currently without resampling. It is a good algorithm, sir. Well, it's just obnoxious because you have to modify the whole format in which you store observations. Because now you can't just store every observation, you have to store the groups. To take means over groups as well. Pretty annoying. I'm thinking how I want to structure this. Welcome. No idea how that's supposed to render, but welcome. So what I'm thinking here is whether I can get away with just doing the min. Just get away with doing the min over the burrito front. Couldn't deal with X anymore. It's Tyler. Welcome. Oh, hang on. Damn it, this is what happens with the Discord stuff. Is I didn't realize that was you. Because everybody has a million different names. Alright, makes sense why you're trying to pick up some of this stuff. Yeah, I mean, this is one of the more algorithm-centered things. This is not like stuff that you'll see a lot of RL people doing day to day. In fact, this is like the type of thing that I like to do. It's a severely neglected but very important area of RL, where getting this right will make everything else just better immediately. But you have to think about stuff quite a bit. I mean, there's like, the math is very simple, but it's like a bunch of transforms that have to be thought about, not just from a math perspective, but from like a learning perspective as well. Why are you allowed to ignore the bottom right points? Throwaway data? Well, they're just they're not considered optimal points is all. You still use them for learning, but they're not optimal points. You're trying to find the set of optimal points on the frontier. Text ain't going through on X. Let me see. It says it's live, but sometimes, yeah, sometimes the servers just eat messages. I don't have any configuration set up to block stuff. I've looked like several times to see if there's a way to fix it. I don't know if it's restream. I don't know if it's X. It might be a rate limiter that they have built in. I don't know. They really did. I don't know. I had a pretty cool interaction where one of the guys there like saw, I think his dad watched my streams or something. So I got invited over there to go chat with some people at X. Um, yeah, I mean they have like it's a cool platform, but I personally would not be happy working on like such an annoyingly big legacy code base. And also I'm kind of man on a mission here with RL. So we didn't really do anything there. But I mean they're cool for sure. That's what this is. I should message those guys as well just to tell them that they've been doing good work on they've been doing great work on X. It's a really good platform. It's got problems still, of course, but I think the way that we're going to do this is kind of silly. I don't think this is ever going to be a bottleneck. No, because the GP is already okay. Yeah, this is fine. How long does the 1,000 runs of Pong take on your server? 6-8 hours on one server. They're only like 30-second runs. Should only be 6 or 8 hours. You don't need the graphics. You do have to simulate it playing the game, but you don't need the graphics. A 1,000 runs of Pong is, I mean, each run is between 5 and 20 million steps usually. We're training on, between 1 and 3 billion frames of data per hour typically. 1 to 3 billion steps of data per hour. And we have way more data than that as well. We're GPU bound. A good goal for my first CPU. I mean, if you play with it, you'll kind of get a sense. These things are like, our stuff runs at least 100 times faster than the vast majority of stuff in the rest of RL. So it's pretty quick to play around with. I mean, stuff like this will make it even better, but this type of stuff takes me a little bit. It's a little more than just that, Captain. Because even if you just use the standard Atari, we're still 30x faster than most stuff. But yeah, if you want 100 or 1000x faster, then you have to use our fancier things. Time to save for a server. I mean, we're gonna have we have a few at the moment. We've got, I think, 9 total boxes, and the goal is gonna be to expand to 40. The 50/90s are so delayed that gives me a bit of time to get some more revenue, anyways. We'd like to add at least one more new contract. Speaking of which, I forgot to check my email. I had to check for formal contract stuff. Dang. Good news for them, not great news for us, dang. That's unfortunate. Oh. No doesn't mean no. No just means later. Are you done with contract work? I'm just waiting. No, we have one active that I have to do some stuff on. But then the other one we're waiting for them to re-sign, which they've said they will. They just they've been busy over the last few days. And a result of E3B. E3B, so Mayzem is getting added to Puffer. E3B, I still have to do tests. That is going to be scheduled for probably tomorrow. Reason being that I want to get this hyperpram stuff stable enough before I start on other things. Yeah, and I have E3B. We're going to do that. That's slated for this week. All the environments are rendered. They're just not rendered during training time. And it's not just because it's cool either. It's a necessary thing to do in RL. You cannot debug without being able to see what is going on in your env. These all have front ends. They all train on partially observed local state. The ones that are fully observed, obviously. Like, the only thing that's redundant here, like the animations aren't even redundant. The animations are necessary because the animations they correspond to state changes in the agent, and you even need that to be able to see. So basically the only thing that is redundant in this whole UI is the fact that I made it pretty by making the tiles all snap together nicely and lerping stuff like this. Like the texture packs and this movement and stuff, that's technically not needed. That's to make it pretty. But you literally do need to have at least render the terrain, render the agents, render some basic animations. All these things are necessary for debugging and for interpreting behaviors. You run simulation to optimize run again. Yep. What do you expect optimizations to achieve? When do you expect optimizations hyperparameters? Well, that's what this algorithm does, right? This algorithm automates the optimization of hyperparameters. Well, I'm working on the algorithm still. The algorithm isn't done. I'm testing the performance of the algorithm, and I'm making tweaks. Right? You have to develop the thing that automates the thing. Something screwy here. Ah, okay. That's awkward. Use Raylib for all rendering? Yeah. You're watching real-time RL exorcism. Yeah, exactly. That's the idea. That is the idea. Oh, yeah, this will be screwy, actually. There we go. This now works. Jeez. Yeah, that's rough. You know, people have like very different. Your PhD is like so very dependent on your relationship with your advisor. Um, I don't know. I was like always doing my own stuff. So for me, with Philip, it was pretty much just like I'd work on whatever crazy stuff I was working on, and then we'd shoot the shit about AI once in a while and like where the field was going. Um, and I had very strong views on where I thought stuff should go, and he was generally just like, all right, I took you as a student because you're competent. That was the general understanding. So you just keep doing this crazy stuff. That's rough. And I saw Philip at the conference lately, and he was like, "What the heck? How have you gotten all this stuff done since you graduated?" Like, Why couldn't you do this during your PhD? And I told him it was like, look, I, as far out of left field as I went during my PhD, I had to go even further out of left field to really solve all the stuff I've been doing. Like I had to completely dispense with the academic way of doing things in order to actually make progress here. I mean, think about it. Like you would never in your PhD, while you're actively researching stuff, and there's always a paper deadline, and there's always a this and always a that. You'd never just drop stuff and be like, I think today I'm going to try writing a snake environment, and then I'm going to port it to C. Like that's just not a thing that you would do, right? Literally, it's like I don't know. People talk about like taking hallucinogens or whatever, and like having like a snap moment. So what I did instead of that is I ran a 50K, and like I completely fried myself. I could not think for 3 days after running that thing. Like I literally couldn't add two-digit numbers in my head. Um, it was like crazy strain on body. Um, and then like 3 days after that, I was just like, yeah, I think I want to write some C. I think that would be cool. And that's exactly what happened. Not even making it up. Moles for graphite cathodes. Huh, cool. Yeah, I mean, a lot of the progress is just found in the problems that nobody's bothered to look at. Never used C before, very little. So I've been working on Neural MMO3 in Python, and I had this snake environment in Python, right? Um, but I really liked that you could render the stuff online with Raylib if you did it all in C. So I just was thinking, I wonder how hard it could be. I wonder if this will be easy or not. And it turned out it's very easy. In fact, it's easier than anything else. Also, as for the thought process, I don't know what the thought process is, man. I was totally fried. I mean, I have an article on this thing. Where's this? I don't know. This is like something I'm pretty genuinely proud of because I mean, like I was not ever a good runner growing up. I ran cross country like when I was younger, but I was always like towards the end, like towards the back of everyone, right? But yeah, I did this thing. I wrote this article as well, like while I was still basically incoherent. Ridiculous. Couldn't look at a couple hundreds of years ago. Wish I could see what Da Vinci could do with our tech. I wonder how people like that would adapt. Yeah, so this is clearly fine. What I want to do with this now is I want to modify the test a little bit. I happened to come off your video from Team Lucid. Oh, geez, that was like my first internship as an undergrad. That was like peak blunder years. I don't know. I wrote that children's book in middle school. I'm sure I lost money after all the publishing and stuff. I mean, that was like, I did that when I was like 12 or something. I have no idea. Been more short or mid distance. I did not enjoy the long distance. I just did it to do it. I do think everyone should do a full marathon at some point. It's a good thing to do. Like just it's personal development more than anything, honestly. But yeah, at the moment I'm just well, I mean I had the pneumonia thing, right? So like I'm just trying to get my cardio back up to something reasonable. So I'm doing just a couple 5Ks and some intervals every week, and then trying to get my strength back as well. Much more optimistic. Oh, I'm very optimistic. The thing is, I'm very optimistic about where the tech can go and what we can build with it. I'm just pessimistic about most of the stuff that's out there at the moment because all the code sucks. I think I'm at least as optimistic as I ever was, and now I actually have the skills to build it. That's the difference. I mean, you honestly have to be very brash in order to make progress in some sense. Because, like, it has to occur to you that maybe the people that built this standard thing that's been used for a while were dumb and didn't know what they were doing, right? Like, you have to be arrogant enough to think that in order to, like, go try to rebuild something that's been used forever or whatnot. Like, you literally cannot be humble and like you cannot have like the mindset that everybody is very confident and and you need to be very humble. You cannot have that mindset to make progress because if you do, you won't challenge the existing stuff and actually find that it's broken. I mean, academia will laugh, like they'll just laugh their way into irrelevance, right? And laugh all they want, I don't care. I've literally had like fourth rate researchers who have never published anything useful or done anything remotely useful and have done like weird theoretical things that don't even apply anywhere. I've had them like come up to me at like my published, my posters at conferences and like ask me if I just do this stuff in my free time. Like, where's my real research? It's like, yeah, okay, see ya. The thing is, I can laugh that off, right? Because it's like, yeah, I've got the pedigree. I'm going to have options to do whatever the heck I want. But yeah, that type of stuff, if you're not in that position, it sucks. Engineers, weird to think of people being, oh yeah. No, researchers have some of the worst mindset. A lot of the scientists do. The good ones are really good, right? Nothing worse than a mediocre scientist. It's 10% everywhere. Sometimes you'll get a little more density at like MIT or places, but for the most part, it's like literally, yeah, that's just going to be what it is. One second. Let me at least get this running. Generational assumption neurons. Yeah, it might be the wrong acronym. Might just be the wrong one. It's funny though. Okay, so the current thing that I'm doing here is I added some noise to this benchmark. I want to see how it plays with noise. So I think that what can happen here is that if you get noisy observations, then you'll eventually get lucky essentially with the noise, and you'll get a point that's too good. And you won't be able to do better than that point because it's better than the theoretical maximum. And your model will figure that out and then stop trying because it can't do any better than that. We're going to see if that's how it works. So actually, I'm looking at this and I think, did I do this wrong? I think that's probably fine. We'll see. Completely broken this though. Looks like it has at least. What I'd like to do, if I can, is I'd like to replicate the problem that I'm seeing on the real environments in the synthetic task. That would be the goal. How do you get those node-like images showing hyper choices? These? You just make a dashboard here. You add a scatter. And then the view that we have here, this is just cost versus score. Next most important thing to accelerate RL after hyperparameter stuff is figured out. Okay. It's probably going to be some core algorithm stuff, I would think. What we're going to do with this, so it depends what you consider the hyperparameter stuff in general, because it kind of all hooks together, Captain. Splines. Oh yeah, I'll show you that. That comes from this. But Captain, that thing is, once we have good hyperparameter sweeps, right, we're gonna run it across a ton of different environments. And I want to see how optimal hyperparameters vary across environments, and then use that to inform modifications to the existing training algorithms that will then generally improve perf across all the environments. So it's probably going to be some core algorithm stuff, would be my guess there. But it's going to be informed by large-scale hyperparameter sweeps. And the key is that you need to really have confidence in those sweeps, right? They need to be relatively efficient, and you need to have confidence in them. So that's what this is trying to do. Yeah, so this is not showing you optimal anything. This is just showing you the amount of compute that you're taking at each point. Accurate and fast synthetic data. Well, we have that for all of our tasks, right? So we have a lot of these that we can use for research. Protein powered. That'd be funny. I might steal that. That might be P30. What the heck happened to this? Why does this not work now? I'm not allowed to change the score? Oh, you know how I should have probably... I should have added noise. Try this instead. I think I just added the noise to the wrong spot. PPPS, that's funny. We'll see what this does. Hopefully this at least gives us something more reasonable. noise task. Good stream day. To give a quick overview of what's going on here, I think that the issue with the algorithm at the moment, this is a hyperparameter sweep algorithm, I think it's just not particularly robust to noise in the observations. And I think the reason for that is if you get a Pareto point that's above where it should be, so if you get lucky essentially, then the model cannot ever do better than that, so it just stops trying. So what I'm doing now is I made a modification that I think should help with this, but I'm trying to reproduce the failure on synthetic data to see if I have understood this correctly and if I can fix it in the synthetic task. 2 presentations. Some people hate the conferences. That's cool. Good luck with those. I think I will be avoiding conferences for a little bit. Just because the last one nearly killed me, so it's a pretty damn good reason, I'd say. And that really breaks it, doesn't it, that noise? I want to see if I can see why in the chart. Puffer themed hazmat suit. I mean, pretty much I've been to brunch. I went on vacation, yeah, but other than that, I've been on, like, since I've been here, I think I've been to brunch a few times and that's about it. It's just like, straight up, nope, stop getting me sick, you disgusting people. %25 noise. What would 25% noise be? Reasonable amount of noise. Starting to maybe see it a little bit. Maybe. I think a more realistic. We'll do 0.1, but it'll be Gaussian. So will be bigger peaks. What are we working on today? Working on the hyperparameter sweep stuff. this algorithm is doing incredibly well, but it seems like susceptible to noise essentially. This is the best run? No. This is the second best sweep that I have. The best sweep that I have is right here. Yeah. So this solves Pong in less than 20 seconds. But after you do around 100 experiments, it starts just doing experiments right here. It starts just running degenerate experiments. And the reason is it's just decided that it can't improve anywhere here anymore. It's just decided it can no longer improve anywhere, so it just stops. So we're going to see if we can fix that. Could you add a flag after you reach optimal performance? Yeah, you actually can. But the thing is, I don't think it's actually reached optimal performance. I think it's just that there's some noise. Maybe this isn't the spot to add it either. Okay, I think actually the best spot to add this would be waste cost. We'll look at this as well, but I think that this will be the better way. Yeah, if you add the noise here, then it can actually break the curve a little bit, which is what you'd want. I think we can even do 20. Well, in this specific case, it means that when you run an experiment, you can run the same experiment several times and get different results. And it can be there can be a quite substantial deviation in some cases. So if you get like a really lucky experiment, right, and then you set that as the baseline, you're not going to be able to replicate that. So the model's just going to stop learning to do better than that because it won't be able to because you just got lucky. Yeah, so this is also not giving me good enough data to even do anything with. Try this. Noise. This tests the robustness of the hyperparameter sweep algorithm. Geez, this absolutely nukes your performance, eh? During my master's, we spent months finding out where noise was coming from in our detectors. Turns out something is a great X-ray detector. Our experiments produce very high power X-rays. We had to put a bunch of lead shielding around the detectors. Well, about the most dangerous part of my work is getting freaking pneumonia at a conference. Don't have to be dealing with that radiation. I probably got a heck of a lot more radiation in the subsequent X-rays and CTs. See, so the rating is already negative at this point, so it doesn't know how to improve anymore. So yeah, this is completely broken it. Huh. This is a lot, like, holy. Okay. Let me just make sure that it's still working. I had a tiny bit of noise. Surely this shouldn't mess it up, right? I'll just do 50. I don't know. I looked up the effective doses of stuff, and the amount of radiation you get in a CT scan is apparently the same as about 2 years worth of normal exposure, just natural exposure, which is also 7 times above the recommended annual dosage. But still about 1/15 of the, possibly cancer concerning dosage. Hmm. Could we just get better MRI machines? Would that just work? If you find a way to produce liquid hydrogen very efficiently. Okay. I mean, that doesn't sound like a harder problem to me than making X-ray design, like X-ray chips better, right? The heck is this? Okay, does this just not work now? What's going on here? Could have sworn that we had this thing. We had this thing working, right? Something screwy. Yeah, the CT is the one that gives you a shit ton of radiation, right? Works instantly, but gives you a ton of radiation. Hey, welcome. Something must have broken at some point with this task here because the base task does not seem to be working now. We will run the full thing to be sure. I could have sworn we tested this as well. This is no game. This is live reinforcement learning dev. Superconducting magnets. Biocompatible too. Is there a reason that they take half an hour or longer? And also, why are the machines so expensive? Okay, good. I didn't break it. It just takes a while here, apparently. How many is this? It does take quite a while here, though. And it gets quite a high score here as well. It just doesn't know. What are you even doing? I am currently attempting to, well, I'm tweaking a hyperparameter tuning algorithm that I'm designing for use with reinforcement learning. So the goal here is that this algorithm, it's derived from ImbueAI's carbs. It's a Bayesian optimization algorithm that attempts to discover a set of Pareto optimal points, that is, points that are, it attempts to figure out what experiments you can run that are going to be cheaper and better than any other experiment you can run, or cheaper or better than any other experiment you can run, essentially. And I have a variation of this algorithm that seems to work much better, but I'm working out some kinks with it. Okay, so this one does work. Oops. Okay, so this one works without the noise. It does work. It takes a while, but it does work. So if I add a little bit of noise, what happens? I think that the key issue at the moment is robustness to noise. I don't entirely know, though. They have to cool the magnets with liquid helium. Okay, so this is the okay. This is the superconducting stuff. Okay, I get it. I see. So that's why they always have all the tanks around. Okay. Question here is going to be why noise is such a problem. I have an automated clinic and 10-minute MRI scan. Well, you actually wouldn't need that much. You would basically, it's a non-invasive procedure. You'd basically need to just be able to do this legally and make it cheap enough that you wouldn't want, like, you wouldn't need to even bother with the insurance for it, right? Yeah, just get your monthly MRI, 50 bucks a month. Perfect. I mean, that would catch like so much stuff, right? If the images were high quality enough. That would catch a ton of stuff. Okay, good. So it works here. It does still work with 10% noise on average. We'll compare this to the other one. And then we'll see where it breaks. It's not completely degenerate yet. It's only a 10% noise difference, though. Oh, it's doing something. In the same number of runs, it looks like it's potentially collapsing sooner. Okay, yeah, so here's the one with no noise, and here's the one with noise. I mean, it can improve. 40. Yeah, it can improve it can improve quite a bit all over the frontier here. But it doesn't see that at the moment because of the noise. If we make it more aggressive, are we really going to see it? Is this enough noise, or is this... This still seems like pretty clean compared to... let's crank it up a bit. Let's see if we still get anything with this. Hot or cold sandwiches? Hot sandwiches. It's not that it's taking longer to converge, it's screwing up the final results as well, I think. Interestingly, not in the direction you would expect. Wait, hold on. This one is here. It's hard to say. Yeah, like this point I think is probably better than you can actually do. We'll see it more with 20 if it actually even does anything. Okay, there it goes. So it still is going to do some higher cost runs. We're not seeing the collapsing back issue though. Not clearly, at least. Maybe. It's still not really collapsed with a low cost. Kind of a little at the end there. Okay, so this is with a bunch of noise. It's starting to look more reasonable. So right here, this thing has basically decided it's solved at 50. A lot of Pareto points here. I honestly don't know if we can say whether qualitatively resampling should change very much here. Might have to just run it, because it's about time for me to go get breakfast anyways. So I might just set up a run to go. Set this up for now. Okay. I'm gonna go get some food, get some exercise, do a few things, and then I will be back probably early afternoon to work on this some more and see what we can do with this. We're getting very close here. There are a few of these annoying quirks, which I think that these were quirks with the original algorithm as well. So we're gonna fix all this, and we'll go from there. I have a bunch of other stuff to work on as well, so we might do a few other things. This is quite important though. All right, so for folks here, we do have quite a few folks on at the moment. All my stuff is free and open source. It's on puffer.ai. You can check out the website. It is a company as well, but the only thing we sell is service. So service is a service, not software as a service. If you are at a company that could use some help with RL, come check this out. But for the rest of you, start the GitHub, really helps us out. You can join the Discord to get involved with development or just come to chat. You can follow me on X for more, more reinforcement learning content.